Hello and welcome to Apropos. This is the show about closure, and we're having guests now and trying to make it visual. So before I introduce our guest, here's our panel. We have Ray,
Hello.
Mia,
Hi.
I'm Eric, and our guest is Juan. Juan
Hello,
Monetta.
everybody.
Hello. Thanks for coming on, Juan.
Thanks for having me.
So we have a bunch of questions, but I know that you seemed eager to just get into the demo, and we're all about that. We'll ask you questions along the way. So
Yeah,
can
sure.
you,
I mean, if you have any question like for a starter, go ahead. Uh, But
should we? Should we? Yeah.
if not, I can
Uh,
jump into showing stuff.
Well, should we ask for a tour of your editor first?
Okay, so editor first. Yeah, I have been like an Emacs user for more than 20 years now. And yeah, I think Emacs was like what got me into Lisp in around like 2004, because I started doing Common Lisp there and Emacs Lisp, all them together. And Emacs was an amazing, like I also got into like seeing and reading at that time about like all this open genera like symbolics computers and all the open genera systems. And I thought that Emacs was the last thing that was kind of that, like this program you were using and modifying at the same time. And there was no like separate thing as like writing the program and then running it. And it was like I can modify and debug the program as I'm running that without even having to restart it. And that was amazing for me. And it still is. I mean, even if I think this is an amazing part of Emacs now, even if you don't use it as a text editor or whatever, I think that part is amazing. And I used to do like use Emacs for everything, like for email and whatever. And these days I just use it for like Git and for my because of Magit, org mode, and of course Clojure with Cider. And yeah, but if I have to program Java, I end up into with using IntelliJ and stuff like that. But yeah. And I also really like Emacs because I like to customize a lot of
mm,
things. Because in the past, I remember like we were like when a company hire you, you end up like using other people's computer constantly. So customization there was like very hard. I mean, you need to touch other people's computer, and now you don't know how to use it. But after, especially after moving like remotely, or people started working with laptops, then like I mean you can really put everything in your muscle memory.
mm.
And even if it's right that if I get like someone else's computer, I mean I'm super, I don't even know how to open whatever the browser. But to be honest, I mean it's happened like uh, so little, so I mean
That's interesting because like that is one of the big things that stops me from configuring more. Is just this idea of like now it's not just other people can't use my computer or I can't use theirs. It's like the tutorials that I'm reading don't make sense anymore. Things are so different. Like I can't get help from anybody because they're like, "Oh, but you just put all this stuff like I don't know how I'm not gonna debug your crazy config for you." Um, I like to keep things vanilla as much like my whole system. I just like to I want to be able to just like buy a new computer and just start using it, like not have to install anything and not
yeah.
I'm I, and I wonder if I'm just like
I like, I
lazy.
mean, I like to have, for example, I always go vanilla when something weird is going on,
Mm,
because I think that's the best way. But yeah, if I'm trying something very weird in Clojure that I don't understand, I tend to go to like the simple terminal REPL or whatever.
hmm.
But for that specific case, just to figure out it is not anything related to an NREPL or Cider doing magic things, or whatever. But it's kind of few cases. It's not like, so I prefer like the power every day and jump into vanilla wherever things
Yeah,
are going like super weird, which is not every day. I mean,
for sure.
yeah.
Got it.
So you got to show us your editor one. That's the
Yeah.
main
Can you
thing. So
share your
show your
screen?
desktop.
Wait, let me see.
Sure,
Do you
sure.
have permission? Might have to do that.
No, I don't have because I tried.
Okay, try again.
Okay, share. Desktop to share thing.
Oh, beautiful.
Why I cannot see? Okay,
black.
okay, yeah. Because I was seeing some Zoom stuff like in the. Can I drag this also? Yeah. Okay. Okay. If you can see there my screen.
So this is org mode in
This
like
is
a
org mode.
presentation mode.
Yeah, yeah. Also, I mean, this is just org mode. I just created some small cheat sheet here for doing some demos, so I don't forget. And a couple of things I want to say before, like if you, I don't know if you're familiar or not with FlowStorm, but I use org mode for a lot of things. Yeah, maybe because you can like I don't use like all the agenda and all fancy, super fancy stuff. But some of the features like to-dos and checklist and a hierarchy for, I don't know, if you are planning for a talk or something, I start to put things in a like in a small tree. So I can
Makes
have
sense,
some collapsible stuff there. And also, I mean, if you need to do like to-dos or whatever, there are things that make everything super handy. Same with, I don't know, things like creating this list and then being able to just complete them or all this stuff. But anyway, yeah, so I'm an Emacs user. And, yeah.
Nice.
And yeah, I don't know, before I start showing stuff, I don't know if any of you have any experience with or know what it's FlowStorm about, at least on the latest versions.
I've
Just to,
never used it.
okay,
I'm very interested in the time travel debugging. That sounds
okay,
really cool.
let's
I've had a
jump
little play
into
with it, but I'm not an
it.
expert at one, so yeah.
Okay. Okay, so before we are in Clojure, and I always like to, I don't know, start or see another project, like what problem am I trying to, are we trying to solve when bringing a new tool? And in this case, I think the thing that made me start all this stuff, it's like, I think interactive programming is amazing. It's one of the greatest thing of like Lisp and enclosure also. And it's amazing that we can like start a process and then add and change functions and run things. But then as soon as we run something, the execution is completely opaque. So it's a black box. And if like just calling a function that's going to call like 1,000 other functions for doing something, even if we have the REPL, which is amazing, but we go and call that and we have like two things, or the result of the thing or an exception, but it's a black box with very little on what's going on. And there's no way of looking at the execution other than logging and tapping. And I think logging or tapping or whatever is super inefficient, because if you have too few log statements, that you don't know anything. And if you have too many of them, then everything is super confusing. And if we cannot see what is going on when we run something, then we have to guess a lot, especially in Clojure, because it's being dynamically typed. We rely a lot on names. So when you try to run something and something is working or it isn't, no, doesn't matter. But when you look at the code, yeah, you need to rely on names. So yeah, I think that's trying to like seeing instead of guessing. It's make like this interactive programming much better. So what is FlowStorm? It's an IDE independent So it has nothing to do with Emacs, IntelliJ, or whatever. Graphical dev tool. So it's a dev tool. It's not for like production or whatever, trying to understand your production system. And it's all about recording and then visualizing Clojure programs executions and data. The data part, I'm not going to demo too much of it because it's kind of the same as like Portal Morse, and it has its own view of the thing. But it's, I think what puts it apart, it's like recording and visualizing programs execution. And all this stuff with interactive programming in mind. So it's kind of like a REPL companion. So it's not like a debugger. I don't like to call it a debugger. I end up calling it a debugger because a lot of people at least associate with something. But it's more for me like a REPL. It's not something that you fire for a particular situation. It's something that is there helping you in many ways. So yeah, and how can it help you? It can help you learn and understand, like from a simple function to an entire system from a runtime perspective. So when you go into a new system you don't know about, you can like read the code, which is harder in Clojure because it's dynamically typed, and so it's less information to read, or you can poke around with the REPL. But if the values are complicated, then poking around isn't easy. So it's something that's gonna help learning and understanding systems. It can help with debugging, of course, because once you understand something, you can like try to figure out what's wrong. It's also helped with interactive and iterative development. We are gonna see some features for that. It can help with static code reading in Clojure by providing like the shapes of the values and all that stuff. And then visualizing like real complex and real-time changing data. This is, maybe we have time for it. But yeah, I don't know if you have any question. If not, I can start like
demo.
Going over.
Go for it. Yeah.
Okay, so the first thing it's what I'm gonna move the cheat sheet here. The first thing is how to install this thing, which I think it's important in all this kind of tooling, how ergonomic they are, and how easy they are to set up. In this case, we can install currently for most projects, we can install it globally. With I'm editing here our global Clojure dev. It's the same we can do with lane profiles, and we can go deep into this, but we just need to copy that into and create a new alias. Just with creating a new alias, in your global dev or lane profile, it's gonna be enough in most situations. So you don't need to put anything on your project, okay? And FlowStorm now supports plugin, and adding more plugins, it's exactly the same. It's just adding more aliases that you then go and enable. So what does it mean? It's when you have, like here, I'm on nothing on my home, I'm not on any project or anything, and I can start a REPL, and if I just add this alias, okay, it's gonna start a normal REPL, but then whenever I need, like I can use this for whatever, but if I need the debugger UI, I will have it at hand by just evaluating this keyword. Okay, which is it's currently hijacking these keywords because I mean it's nothing. Just evaluating a keyword on a REPL doesn't nothing that people will want to do, and so because just evaluate to itself, and you have the UI. Okay, so it's that's an important part for me because you don't need to add anything to your projects, and then with a simple keyword you have the UI whenever you need it. So for demoing it, I will instead of like just using a REPL here, let me start like a proper Emacs REPL. This can be like VS Code or whatever. I'm just, if we look at the depth hidden of this demo project, so I created these demo projects just for showing things up. But if we look at the depth hidden here, there's nothing related to FlowStorm. So these are just dependencies for the database stuff and web stuff for the demo itself. It has nothing to do with it. And so if I check in here, yeah, I'm starting a REPL here, and I would normally do, I start a REPL and hit the DBG keyword, and I have it there. And what I do, let me increase the font a little bit here, is I just send it to the background. In this case, I'm using i3 or whatever, but what I do is like I just leave it there. It doesn't do anything, and I have a keystroke to bring it whenever I need it. Okay, so let's move into something here. Now, let's say I have some simple functions. Doesn't matter to understand them, but let's say we have like a quicksort here. Normally what we do is we come here and run it. And if you want to understand it, what you can do, or because you are chasing about, or because you are simply trying to understand it, is you're going to break the UI and just click record. Okay. And when recording is on, you run the thing, and then you can pause it. I'm not interested in running it anymore, in recording anything. Okay, and there's a lot of things going on here. First, it's gonna tell us that it's recorded activity in one thread, that is just an REPL session thread, because if you have like running something into multiple threads, then you're gonna see like recordings into many threads. And then we're gonna start like, there are many, the thing is like we just recorded everything that happened when that quicksort executed for this input. And what this UI is going to provide, it's access, like many ways of looking at that. The simplest thing is or what most people is used to, is stepping. So we can click step here and step. So our pivot is 3, and then we go and evaluate our collection. We can go back and forth in this, and here you're gonna be seeing the values. So this is the collection. We have the type here, it's a chunked sequence, whatever. But we can also, like, not only single step, but we can also click around. For example, what's the return of this filter? What's the return of this collection, or the smaller than pivot? So we can like really single step, and now this is into this function, and now we are comparing B with pivot and this, and it's false, and now the next, and all this stuff. Or we can, the current function frame, it's gonna be highlighted. So now we are in this function, and we can click around, like this is gonna call this recursively, for example, and we can see whatever quicksort returned, and or we can go here and then go into it, and now we are in the recursive call. Okay, so, but this is, we have like some tools here that allows us to do, for example, the like jumping with the going into something, or this is jumping over. So don't go into other functions, just keep moving forward or backward, but stay on this function. Here, this is another important thing. It's we capture like 416 steps, and we are on step 100. You see, if I hit next, I'm moving through the steps here. But we can go to the beginning of the recording, which is before calling this, or we can start moving around in time. So, but this this is one way of looking at execution at a very fine grain level. Another
So
way,
can I stop you here while we're
sure.
here before you move on? So I noticed a couple things. Um, One, it just hit me while you were showing this. You didn't actually go into filter V, right? Like when you clicked next, it didn't load up the code for filter V and show you the whatever loop it's got for building up a vector from that collection. But you were
Exactly.
stepping into the code for the inline function that you're passing in.
Yeah.
Um, and it struck me that that is the reason I haven't really liked debuggers, especially for a language like Clojure, because we're constantly calling these, we're calling so many functions in this really densely packed way that so often you're just like jumping to standard functions, and I don't want to see
Yeah.
that. I want to stay in my function where I'm working.
Mm-hmm.
But
Yeah,
I do
exactly.
want to jump to something that maybe I defined
Yeah,
elsewhere
exactly.
in my own
Okay.
project. And so I wonder, how did you solve this? Like how
Okay.
does it choose not to go into filter V?
Okay, that's a great question. I didn't went into that yet, but FlowStorm is not gonna record absolutely everything every time. You are gonna, there are many ways of telling it what namespaces you are interested in. Okay, and it's because we are
Mm,
running it without any configuration, it's gonna take it here. You can see all the things that it's here at the bottom, all the things that it's instrumenting automatically, and looks like a lot, but I will explain. The thing is, because our top level namespace is big demo, when we start it, it's gonna, by default, it's gonna say, okay, I want everything inside big demo, whatever. Doesn't
mm-hmm,
matter.
mm-hmm,
Okay. And
mm-hmm.
all these other things are here just because I have added a bunch of plugins here for do some other things. And the plugins with themselves brings like, well, if you want to use this plugin, you need to
Uh-huh.
instrument the internals of
The
Jetty
Jetty
or
adapter. Yeah.
whatever.
Yeah.
Okay, but
But
that's only
most
because of plugins.
libraries are not included. So all the other things like your
Yeah,
filter
I
V is
mean, if I don't add the plugins here that I added just for a demo, um, you don't see this. You just see big demo there.
got it.
But as you're gonna see next, we can on demand without restarting the REPL program add more like libraries and namespaces that you are interested in recording.
I
So it's
see.
not like you started with this and now you don't have anything else. And there are ways also, that we are not going to cover here under user guide, but if you want, like, I want to instrument like everything inside big demo, but these namespaces, like skip these ones because they are super
Mm-hmm.
noisy and I don't know. Um,
Yeah.
so yeah, if that's
That's cool.
answered,
Hmm.
yeah.
And then I like that it's recorded, that you can jump around. It's not just like step forward, step forward. Hey, oh
Yeah,
man, what was that thing I just saw? Oh, I missed it. I gotta start again.
yeah, exactly.
It's
And
recorded. You're actually able to interact with it.
yeah, and that
And
opens like a lot, as we are gonna see now. So next thing is um, we let's show like this first. For example, we can, if we are looking at a value like this collection, this is a persistent vector. We can look it like as a preview like this. This is a persistent vector, like smaller than pivot, whatever. And we can, if we are interested in, I don't know, trying something with this sub value, we can define it like def here, and we call it smaller than or whatever. And then we are going to have it here. I didn't namespace it. It's
mm,
um, so that allows us to also bring whatever value we are seeing there back into the REPL, because now we're going to try our code with its sub value or whatever. The same we can do, for example, here we are going to see like all the locals so far. So if we are here, like we have all these bindings, like the collection and the pivot, and then these two other things. We can also do things that sometimes is super nice for developing, that you can right click here and do like define all of them. Okay, and now they are all defined globally in our namespace here. So these expressions have values. So we can try some expressions here, no problem. Instead of like going there and add some def or bring in another library like scope capture or whatever that's gonna def it for you. There is very easy to just define this on the namespace. And then you can try smaller things, which is convenient for development. But so yeah, the other tool, for example, you can use is like, well, I don't want to see like small pieces of it. I want to see the execution tree. And here, moving to the tool which shows the execution tree, we are going to see like all the functions that are being called in a tree. And because it's a recursive function, quicksort is being called again and again. And here, by clicking on this, you are going to see the arguments and the return. These are all the less than predicate on the filters, on the greater than predicate, that again, you just click them and see what they return. And if you're interested in like, well, I'm interested with this greater than predicate was called with the argument 0 and returned false, you double click there and it's going to take you to that particular call in time. So that's another way of traveling around in time. Now we are here in that particular call. So it's not that you start from the beginning on a system and just click next forever until you reach the part you are interested. You have other ways, for example, like coming here and start expanding the tree. And well, let's see what happened with quicksort when it's called with the empty arguments. And now we are here. And the pivot is nil, so the when is not going to do anything, just returns in. So that's another thing. There is another tool, another like way of like looking at a higher level, whatever you recorded, which is the functions list. The function list is going to list all the functions sorted by how many times it was called. So quicksort was called 21, and these are a little bit more. But whenever you click them, you are going to see here all the function calls for that specific function with the arguments and the return value, arguments and return value. So you can go and the same thing, say, well, here it's interesting, it returned 7, 8, and you can take a look at these arguments if you like. Same with the return value. But if you're interested in this particular call, you find interesting for whatever reason, double click there. Again, you are in that particular call. So that's another way of like jumping around, moving around, this function being called with 8. Now we are here being called with 8. Yeah, so those are the basics. Let me see if I have anything else here. Oh, okay. And another basic thing, which I think it's interesting, it's that you can, these things called flows here are like audio tracks or whatever. So you can record many of them. So if you're interested, for example, in this quicksort, I'm going to store it on flow 0. And now I'm going to move it to flow 1 or whatever and hit record and run it with, I don't know, different arguments. And now I have both to compare here. And they are like two completely separate recordings. I can and this is interesting when you can record something that works and then with a different argument doesn't work or whatever, and you want to like compare both flows. Yeah, so that's kind of the very basics. Here you always have like the locals and also the stack trace. So how deep we are. And on the stack, this is like kind of like normal debugger, and you also can, of course, like jump to any point in time by just clicking on the stack, and it's going to take the debugger to that point in time. And from there, you can again go back and forth. So that's for these tools here. Now, let's the way I use this tool normally is just there is a short a key binding which is like the same on the terminal, Control L, which is the same as this trash can, which is gonna get rid of all the recordings. So what I normally do is like I keep it clear, and whenever I in the background, and whenever I need it, I just come here, click record, run something, and then go for it and take a look at it, and then just clear and get rid of it. So it doesn't take any heap space or whatever. The garbage collection is gonna take care of all the recorded stuff. So next, moving to, for example, this is just some random function, doesn't matter what it does, but this is a common thing on Clojure. You run a function with 72, whatever, it works. You run the same function with 70, and suddenly you get, well, null pointer exception because X is null, and for beginners, this is like, what? Like, I mean, if you look at this, what is null? I don't know, range, odd, partition, map second, drop 10. It's
Right.
if you learn about reading the stack trace, of course you're going to say, well, it looks like it was before the add, so we have a reduce, so probably something nil fishy, it's around here. But then there is a lot of guessing or modifying the code or putting stuff. While here, what we can do is just hit record and run the thing, and now we are going to see that recording happened. Of course, the exception happened as normal, but now we have like an exceptions combo showing up here that it's, yeah, we capture this null pointer exception and we can go there right before the exception. Okay, so then we can step back. We see the null pointer exception here. Okay, and we can step back. And here we can see the drop 10, yeah, was for some reason generated a lot of numbers and nil. So this is the problem. But so the reduce is going to try to add all these numbers plus the nil. But then where this came from? Well, one step back, map second. We are still
Uh-oh.
Oh no.
generate.
Sorry, Juan, you're frozen a little bit.
Oh,
Are you there? Are you back?
You're back again.
Okay, good.
Can you hear me? Okay, so I don't know if
You can rewind it a little bit, can't you? That's
Yeah.
the good thing about this.
Yeah, yeah. You were just rewinding from map second. And
Yeah, so from map second, we can see the nil here, and we can keep going back because I don't know where this nil is coming from. So we go back one, and we quickly figure out here is because partition all two is going to generate a bunch of tuples, but one of them only has one number because it's this filter all returns like an even amount of numbers, but it's pretty easy to, oh, okay, this is because partition 2 is sometimes is going to generate like tuples with only one or whatever. And you can also configure this, for example, to auto jump to exceptions. So whenever you run something, it's going to take you there. So you hit back and you are there. So when I use this, I rely a lot less in error messages, because if you can, I mean, of course, I want to read exceptions to see what's going on, but yeah, then I can play around here and see quickly, like, okay, yeah, I have a nil, it shouldn't be nil there, whatever, and yeah.
I like this
Wow.
because pipelines are annoying to debug. That's for sure.
That's
Yeah.
right. That's true. But this is
Yeah.
great. Like you can see the input and output of each thing.
Yeah.
Well, can you see the input? I said you can see the input. You can obviously see the output of the one previous to it.
Yeah, exactly.
So, wow.
So-
That's, I mean, that's going to be a game changer. I mean, I already want to use this.
Mm.
I'm going to set it up as soon as we're done recording.
Yeah,
So
it's much better than a debugger. I really like that you can choose which function you want to see the input and output of instead of just clicking through and waiting for it to pop
Yeah.
up on the side and hope that it doesn't crash your REPL,
Yeah.
which I feel like is my debugger experience.
And the fact that it works with macros You know, I think I've used a debugger where like once you expanded a macro, you're like, I mean, there's nowhere like you put a breakpoint, but like where do you put the breakpoint
Yeah,
when the macro gets expanded into something else?
yeah.
But this is working with the threading macro, and it's amazing. It's great.
Yeah, yeah, it works with most macros. There is a section that I have there for the. I mean, it's on the user guide, and I was going to talk about it with like current limitations, which are macros that destroy meta as they generate code. So that's important because the only way we have for going to, because the compiler after macro expansion is going to compile something that has nothing to do with your original source code. So the only way of mapping things back in this case, it's that it's gonna, before expanding the macro, it's gonna annotate with meta like the coordinates of everything, and
Right.
then it's gonna macro expand, and then the compilers it's gonna know, okay, this is coming from here, so
Yeah.
it's gonna keep a
The
reference.
coordinates in the original code have to get.
Exactly.
Yeah.
But if the macro, there are a few macros that are super crazy, or because they are written in a way that doesn't preserve meta, then there's no way of matching back. But in my experience, I mean, most macros just work. And for the one that doesn't work, you just don't get the thing highlighted there. It's not going to break your program or anything. You just don't capture the thing because you don't have a reference. But yeah, now let's move on and see a little bit of like libraries, for example. Let's say we are, I don't know, having, let me evaluate this. We want to encode something base 64, and yeah, and we want to try to understand how this library works inside. Okay, and as you can see, we don't have here on the browser, we don't have anything telling like instrument anything inside Clojure data codec. Okay, so if I hit record here and I run this, I will get a very shallow thing, like 4 steps, which is the stuff like, okay, the bytes and the encoded bytes, and I cannot go into because there's nothing recording that. But it's pretty straightforward. We can come here to the browser, look for the base 64 namespace, and we can add an instrumentation for, I don't know, Clojure data codec, base 64, whatever. Okay, it's gonna tell me because that is already loaded on the JVM without instrumentation, it's gonna ask me, do you want to reload those namespace? In this case, we want, and this is using inside something like very similar to CLJ reload or tools namespace or stuff like that. So if we go that and we apply that, and we clear the recordings, whenever we run it again, okay, we are gonna see now we capture 433 steps, which means we can go into things, okay? But again, there are other ways of moving. Well, let's push a little bit further. No, I don't want to go into this one. I want to go into this one, which is more complicated. Okay. Okay, and here, this is another thing that is, I think it's interesting, that it can help with static code reading, because, for example, if we are trying to understand this, what we normally do, if we don't have, like, for example, like FlowStorm there, we're going to go here with our IDE and hit this, and then go to the encode function, and now we are here, okay? But because Clojure is dynamically typed, then, yeah, you see, like, things here, like B2 or whatever, and it's hard to know the shape. In this case, because this is gonna work a lot with like numbers, maybe it's not that hard. But if these bindings are things like user and whatever, an account, then I don't know if this is a map or a vector or things or whatever. And this is gonna make that easier, because as you read in here, trying to understand the thing, you say, well, what is this output here? You can click here, the output. And here is one thing, because if I'm clicking things here outside any loop, okay, it's gonna take me immediately there. But because there is a loop here, whenever I click something, whatever it is, it's gonna ask me, well, this input, I mean, has a value for a lot of iterations. And you need to choose one, okay? You have, in this case, input is always a byte array. But let's click here, for example, it can tell you like it made 5 iterations, and in the first one it was 108, in the next one it was 117. And if you click there, you're gonna go there, but at that point in time in the loop. So there are ways of moving around in loops also, where it's, I mean,
this is great.
yeah. So again, this is gonna help, of course, reading this thing, because if you, I don't know, you want to see what is like A looks like here, you can go here, doesn't matter the iteration, and you can see, okay, it's a long and it's 16 or whatever. So it's gonna help with static code reading also. You also have all the bindings there.
This is really amazing. So please take this with that in mind. I'm just wondering, um, how far would it, or how much work would it be to make it show you all the values in a let next to the code instead of having to click on them? Because the let, is already usually one variable per line. It'd be cool if you could see them. And then the
Yeah,
next step would be to show all 5 iterations at the same time, one next to each other,
yeah.
right?
So
In different columns.
that's I mean, it's great, but the thing I found with that is as soon as you move outside like very basic like longs or very simple things, it doesn't work, because if you're working with like, I don't know, the loop is going over like your super nested map users or whatever, it doesn't
It
fit,
doesn't work. I see. Yeah, it
because
makes
you are gonna
sense.
have like, it's so for
Yeah,
numbers it's super nice, but for anything that numbers, even strings, it's gonna take like a lot of space, or you are gonna have to like,
I see.
uh,
That makes sense.
but so
I hadn't
okay,
thought of that. I was just thinking about numbers
yeah,
because, I mean, it just saves you so many clicks, to be, oh, I want to
yeah.
see what's this one, what's this one, what's this one.
Well, but there are other stuff for that,
Okay. Okay.
but
All right. All right.
yeah, other ways. For example, I was going to demo a little bit after, or no? Yeah, here. For example, if you here you have like the row at the top here, it's like some stepping controls like these ones, like last, first, back, and forth. But these are called power stepping, which means like you choose, like they are gonna step, but you choose how it's gonna step. And there is one power stepper, which is, for example, the same coordinate stepper, which is take me to the next step, which is on the same source coordinate here. So I want to step, but not moving from here. So if I go there, look at the numbers here, it's gonna, oh, sorry, I click something else here. It's gonna be moving,
But
but
through iterations
through
instead
their
of,
iteration, but staying on the same form.
uh-huh.
So there are other ways of like, if you're looking at, let me see this, how it's evolved.
Okay, that's cool.
But there are other ways also that we can. I'm gonna show it a little bit after.
We have a question in the chat for whether FlowStorm can step into Java classes and code.
No, it's everything Clojure. So for Java, I mean, you can combine it with Java, but not with FlowStorm, but you can have your IntelliJ also open there and put a breakpoint on Java and have everything at the same time. I have done that before, but then you jump to the Java debugger, and and do it there. But no, this is only for Clojure and Clojure script also. I mean, all this stuff also works in Clojure script.
Wow.
So it's not.
I have a hard stop, so I have to drop, but this is very exciting. I'm going to put this in my computer once I'm done with my meeting. So thank you so much.
Okay.
Enjoy the rest of the demo, everyone.
Okay.
Bye, Mia.
Yeah, I don't know if you want to keep going.
Yes, please.
Yeah,
Let's keep going.
Okay, let's keep going. So, okay, there's another thing that is with quick jump here, which is very practical. For example, that if you, it can let you jump into, let's say we are interested in this encode function, and we just know the name, so we run something, and we're gonna go there. So we type encode, and we select the function, and we go there very quickly. So if you know the function name, it's gonna be on the recordings. There is a way of like just going right there. Okay, that's another thing. Okay. Yeah, another thing here, it's like I have been clicking this record button. Okay. And there are two record buttons. By default, when you are recording everything that happens on every thread, but you are not recording like the thread interleaving timeline. So how threads are interleaving themselves. You just record them separately. So you can, for example, I have some code here that it's gonna just parallel map quicksort on this shuffle collection. So it's, I don't know, multiple runs of quicksort in multiple threads. And if we run, haven't defined this. Okay. And if we run that, we are going to see that stuff happen in many threads. So the thread that ran the PMAP was the REPL thread, but then like the Clojure agents pool, you can open them, and they are running the quicksort themselves. So you can see like other, and yeah, so you have multiple running in parallel. You can explore whatever is happening, this thread, and this thread. But if you are interested in the interleaving of everything, you can just hit this button, okay? Now, you also, on top of that, you're gonna record like another timeline with thread interleaving. So if you record that, okay, you have the same tools as before. Nothing changed there, but now you can use here, you have more tools on this side. And one of them is a multi-thread timeline browser. So if you have recorded a multi-thread timeline, then you can see it. And you should be seeing like for each thread, these are the thread names, and there is like with thread ID, and there are different colors for different threads, and you can see how they interleave, and you can just double click here and jump to that point in time in that particular thread. So, I mean, moving around time is just clicking around and going to that piece of code. Yeah, so that's another. Or you may be interested only on the functions and not in all the expressions inside, how the functions interleaved, whatever. Yeah.
So I have a question.
Sure.
How does this work? What are you tapping into? Is it using the JVM debugger protocol?
No, I'm gonna show you it right after.
Okay, all right.
I think the next thing it's about that, but that's a really good question. It's yeah. So the thing is nothing else to show from here. Yeah. Okay. So if you go to this thing where I install the aliases that does the thing, you're gonna see three things here. One, it's some JVM option for configuring thing that doesn't matter. Then it's the FlowStorm dependency. And the magic is coming from these two lines here. We are not running directly the Clojure compiler. We are swapping the Clojure compiler by a fork. I'm just maintaining by tracking that it's a first time you see this, it's probably, well, I don't want to run with like another Clojure compiler. What is that? So yeah, the thing here is this. First, it's a very simple modification. It's a patch that I'm just tracking the Clojure. I have been tracking it for a long time. So whenever some new commits come into a release, I will just like rebase my patch on top of that. The patch just adds some places where it's going to emit some extra bytecode for tracing stuff. So it's not changing the internals of the compiler in a big way or anything. But the other interesting, I think interesting not, but the other important part here is this is only for dev. So your test, you are going to run with the Clojure compiler, everything with the normal vanilla thing. So it's something for help you with development. And you can just remove the alias and run with the normal.
Right. So you're instrumenting the code so that it knows the entry and exit points of every
function. We can see it
function.
here. For example, I have even an example for this. So by default, instrumentation is enabled, which is this thing. Okay, you can make it not enabled. And this is important for profiling or other stuff where you don't want to, like, I don't want to be, I don't know, profiling instrumented code. I want it to be like the normal Clojure code. And I don't want to restart my repo. Okay, so if you instrument this, I mean, if I don't have instrumentation enabled, let's compile this very, very trivial function. And if we decompile it, let's decompile it to maybe to Java, so it's a little easier. And here it's just calling numbers add, okay? But if we have instrumentation enabled, and now I decompile the same thing to Java, you are gonna see like your numbers add here thing, but you are gonna see more stuff. Like it's gonna be tracing the function call saying, hey, this function with this name was called, these values were bound, like A was the thing or whatever. And then you're tracing expressions and you're like the expression of A and B, and then you are capturing the return of numbers add and tracing that, and then tracing the function return. Okay. This project, which is called FlowStorm, the one that's the other dev compiler, it's completely decoupled from FlowStorm, so you can use it for whatever you like. It has these hooks for what's happened with when a function is called and all this stuff. But yeah, so
okay, no, that makes sense. I get it now. It's
yeah. So if you need to profile something or whatever, you just like remove instrumentation, compile the thing, and then just it's your vanilla Clojure. Nothing to worry about there. Yeah. So another thing, if that answers your question, is what happened with mutable values? Because all this is possible because, I mean, we can do this in Clojure and people cannot do this like in Java, like we do, or in any other mutable language. Is that because we are mostly working with immutable values, recording something is just grabbing the pointer so the garbage collector doesn't take it. Because the snapshotting system is already there on the immutable data structures. We don't need to, like on mutable languages, if you want to I mean, you have two ways of if you want to record everything, or you take a snapshot on the entire memory at every step, because anything can be mutated, or you grab like in the case of Java, for example, you intercept like everything that can mutate a field of an object or something like that. But that makes things like super expensive because you're not capturing values, you're capturing mutations. So every time that you want to see like step number 100, you need to come up from the front like going with all the mutations to see, well, what is it, this value at this time, because it depends on everything that happened before. But here in Clojure, that doesn't matter. We just, I mean, we don't need to deal with that. But if we are working with mutable value, which is a common thing in Clojure, like, for example, here on array list, you are gonna realize that if we run this, okay, and we check the array list, this is creating an array list and then just adding stuff and counting it, nothing. But on every reference, it's the same reference. Okay,
Right.
so it's yeah, this doesn't, it's not something super useful. Okay, but what FlowStorm provides, it's a protocol that you can, for example, which is called snapshot value, that you can extend. So whenever FlowStorm is about to store a reference, it's gonna snapshot that value. By default, that doesn't do anything. Bless you.
Thank you.
And but you can, for example, say, well, I want to go in the middle there. Whenever something is about to store a reference to an array list, I want to instead store something else. In this case, I don't know, a map saying, hey, this is an array list and these are my snapshot items, and I put that into an immutable vector, for example. Okay. This is important to be in some non-instrumented namespace, because if not, we are also like recording this process, which is useless. So after you do that, now if we run this code, okay, now if you check here, you're gonna see, okay, this is an array list with empty, and here's also an array list empty, but now here is an array list that contains hello, and now hello world, and we are returning hello world. Okay, we have ways of snapshotting things, yeah, so this fixes the other thing, what happened where non-immutable values. Okay. Yeah. So we have
all right.
more.
So can I ask you a question?
Sure.
This is very impressive. I assume you're working alone on this?
Yeah.
How long did this take?
Well, it was super incremental. It's not like I came with like, I mean, the plan of implementing all these features. There has been contributors, but mostly, I think, yeah, mostly for small fixes. And yeah, I mean, I have been working it for like 6 years, I think.
6 years. Okay.
Yeah, probably. On and off, I mean, depending on my job. Currently, I'm just doing this. So
okay. That, I mean, it's very impressive. You can tell
thanks.
It's been years. It's just, it works. I mean, it's got so many features and things. Can I ask what the GUI is built with?
It's JavaFX.
FX, okay.
Yeah. So I started with, I mean, this iterated over a lot of things. In the past, it was on the browser, then it was like CLJ effects, and then, but because I wanted to be the thing to be like super as performant as I could make it, and when I was using CLJ effects, it has some abstractions that when performance matter, then you need to understand the abstractions there, because it's kind of reactive and all that stuff, CLJ effects. And then I needed to deal with that. So I went into that code base and I wasn't finding myself around. And it was like, yeah, let's move it to plain JavaFX. And it has been, I mean, JavaFX has a lot of issues. I mean, but the API for me, it's okay. The issues I've seen is like you move from one version to another and they break things, like, I don't know, weird things, like this table doesn't align anymore and whatever. Yeah. But
got it. Awesome. This is great. This is amazing.
okay. So now for showing it on a little more real world example, because we have been seeing like very small functions and how I use it, I have here a very small, let's get rid of that on this, a very small web app, which is just for a demo that is some very basic composure and JDBC next to do thing. We can start the server here from the REPL. I need to load the space, and we start the server. Let me open Firefox here. Let's get rid of it. And that should be on localhost on that. So very basic thing. But what, for example, when I come into this kind of application, sometimes you want to know, I don't know, when you are loading this, it's going to the database, processing the thing, generating HTML, sending it back, and all that stuff. And yeah, you can try to guess all from reading the code, or you can come here to FlowStorm and just hit record and refresh. And yeah, now you have everything. Or the same thing with the multi-thread timeline, which doesn't matter in this case because it's everything is in one thread. But yeah, now you can single step it from inside HTTP key server and look at the request. And we can see the request here, dig into the headers or whatever. And then just like click it and follow it. Okay, it got into this get thing, into render main page. It's gonna grab all the to-dos. You can go into the to-dos and all this stuff.
Nice.
But then there are other features that I find interesting. It's like a lot of time you see something here and you see like, okay, here it says like apropos, for example. And I want to see like all the places in my recordings where this is something is evaluating to this, because this in some place is going to be coming from the database, and some other place is going to be rendering to HTML or whatever. So you can come here to more tools, search, for example. And you have many ways of searching, but let's search by string. So apropos there. And if I do search, it's going to show me like all the in the same thread.
That's amazing.
All the places. So we can go from the very bottom of the thing, which is inside next JDBC result set, when it's, I don't know, taking it, reading the column by index or whatever. And then building up. Here we are still in JDBC next, but
so you added a search engine to a debugger so that you could search for like, where's this number 3 coming from?
Yeah. So the thing is, because you have like everything is, so I talk some for the Clojurians meetup where it was called like a refine execution. So once you have like execution as data, then you have like a data visualization thing. And because it's data, you can search over it, you can graph it in many ways, you can do whatever. I'm going to show a little bit after. We can access all this stuff from the REPL. So if you need to like really look for a specific situation using code, it's very straightforward. You can go over the timelines yourself. You don't need to use the GUI.
Oh, wow.
But this, for example, here, it's yeah, you can see it when it's like putting it into hiccup and stuff like that. There are other ways of searching. You can search by a predicate, for example, like take me to all those places that are, I don't know, are a map or something, okay? Or whatever. You can say that are a map that contain this key, but doesn't contain this other key or whatever. I'm just gonna search for that.
Yeah, fucking amazing.
Yeah.
Oh, wow.
So this is other ways of moving around in time. There are other ways also that I think, because there are some times that print statements are useful. for example, because you want to see, you have like 10 functions working, calling each other, and you want to, like, you put print statement because you want to see how they interleave. That's a normal thing to do because you in the console, okay, this is interleaving like this. Here we can do it also without having to rerun anything. So for example, you can have this done. That is going to be sometimes false and some, let's, yeah, or whatever, text or done, doesn't matter. We can click here, add to prints. This allows us to create like a virtual print where, is it done? It supports expressions also. And now let's add it to this one, add to prints, text. This is like whatever you would add in a print statement.
Print line, yeah.
But then you can go to the printers here where you see and can modify all your prints and just run them, and you're going to see them. But the difference is
post facto. Like, that's amazing.
Yeah,
I already ran it. It's not working right. I don't understand it. Let me add some prints.
Yeah. So, but the interesting part, I think this is much more powerful than print because of two reasons. One, if it's too noisy, you can like disable the text one and rerun them, and now they aren't bothering you, and it's just a click away. But the other way they are like, it's that you can use this print to jump to that point in time. So they are not like dead prints.
It's very Brett Victor.
Yeah, so everything, it's now you go to that point in time where whatever this function was dealing with review pull request or dealing with apropos or stuff like that. Okay, so yeah, and yeah, then there are, I can show you with the web here some more stuff. For example, if we add another to-do here, this to-do app is like doesn't validate anything. Another to-do, I already have that, and we record whatever is doing for adding another to-do. Yeah, now if we click here, for example, and there's a place that it's extracting from here, from the request params, for params, it's extracting the to-do text, which is another to-do. And we want to follow it over. We can use, like, for example, the identity power stepper, which is take me to the next thing that is exactly the identity, the same pointer as the thing I'm stepping currently.
So the same value basically returns the same value.
Exactly. So I can go and say, okay, let's follow this another to-do. And it's now here. And then it's now on the insert into the database. And then it's now into this whatever next JDBC thing is putting into the thing. We can keep going forever.
Wow. And, I mean, see this. Okay, you know how I said at the beginning that like maybe configuring is not great? What you are showing is like why building your own tools, even configuring your own tools, is amazing, right? Like, you probably have dealt with I'm just guessing, right? You've dealt with debuggers in the past. They've been useful enough where you're like, I see why I want one, but it's not doing what I need it to do.
Yeah.
And so you had this frustration, and you went all the way with it, and you built your own debugger that lets you do all these cool things that you probably always wanted to do with the debugger that you found very useful.
Yeah.
And like you can just keep adding these things. Like, what other kinds of stepping can I do? What would I, and so like before you click anything, you're like, what would I actually like to do next? Instead of like, giving, like I've used GDB before. We have to like learn the 5 different letters but you only get 5. right? Or
Yeah.
however many they have. But this is your tool, so you can add
Yeah,
more.
and there is something around that. I think we are almost reaching that part, that it's kind of infinitely extensible. Okay, let me show one couple of more things, and I'm going into how we can like um, add more stuff into this. I mean, stuff that is for your particular domain or because all the stuff I have shown so far are for like general Clojure programs. Has nothing to, I mean, it's the same if you're working with a compiler or with a web application. But before, let me just show you another very small feature that I think it's nice. It's sometimes if you are looking at the code and you really want to see like, I want to jump it record and jump it immediately, jump it here, for example, you can add it like it's called a debugger statement. This is the, sorry, and break the if here. This is for people coming from JS. This is people sometimes used to put the debugger statement there. And what it does, it's we still are going to record stuff, but it's going to take us there as soon as we have a recording for that. This is make it super easy if we are working with this piece of code and running it many times because we are modifying it or whatever, then we come here, do whatever, we're going to be there very fast.
Wow, nice.
This is just, yeah. And the other thing, the last thing for the web thing here is like when you are trying to understand the system, you normally go back and forth and start trying to figure out, and then you need to, for example, I don't know, get the point where it's here. I don't know. You can put a bookmark here saying going to the DB, and then I don't know, after this, you are moving around in time and you figure out now that you are building your to-dos, hiccup, and you put another bookmark. Or whatever, and then you have these bookmarks that all this other bookmark here is because this debugger instance also add bookmarks. There are bookmarks coming from the API, but the thing is you can start collecting bookmarks and then I mean you can use them to jump around. So when you're trying to figure out a complicated piece of code, you can start putting bookmarks everywhere you find interesting, and now you have like a map of all the the things that you are interested in, and yeah, and it helps you create your mental model of the thing.
Oh my goodness, so great.
Yeah, so next thing we are gonna see, it's like the programmable aspect of all this. It's so far, I mean, the recordings are there on the runtime, and we are using the UI to explore them. But we can get the timelines. So, for example, this is flow 0, thread 209. Right? And we can get the timeline. Okay, and the timeline, it's gonna be just a sequence, and we can use everything we have for enclosure for, let me put it like this, for sequences. Like I can count them. They are 1,000 steps. If you look at this this number here, it's showing -1 here, doesn't matter. And you can take from there, like, or you can take them as immutable maps. And now you have like a function call followed by an expression that resulted into this. And all this stuff we can we can programmatically access all the timeline, because the timelines here, like for each thread, it's basically an array of things that get recorded there. That could be a function call, an expression trace, or a function return, all that stuff. But the timeline implements most Clojure abstractions, so you can map over them, reduce, do whatever. So you can write code to, I don't know, identify patterns in your recordings, give me all the requests, give me all the access to the database, give me all the whatever. And this thing motivated me to say, okay, maybe some of this stuff, like we create some, for example, ways of extracting access to database from a timeline. And then we can maybe share these like pieces of code, okay? So that's motivated the plugin system, which is a way of extending FlowStorm in a way like, for example, here we have web. The web plugin, what it does, it has some ways of like some program to go over the timeline, for example, and extract the requests and response of that it defines on the timeline. Okay, and if you do like this, we are gonna see. Let me grab a fresh recording of the thing, because we have been accumulating some recordings there, like that. Okay, and now let's mark this as down or something. We have recording for all of that. And now if we come to the web plugin and we say extract everything you can from there, you are going to see, well, I can see on the timeline something called the method get, and then it went into all this function. We ended up doing a select after.
Oh, wow.
From the database. And then in another thread, something made a post to mark it down, which ended up doing a query on update to do, said blah, blah, blah. And you can, by double clicking here, as everything else, you can jump there in time. So
wow. So let me see if I understand. You're taking the trace, or whatever the instrumented sequence of steps is.
yeah.
It's just Clojure data structures.
Yeah.
And you've written a plugin that will process that and visualize it in a domain specific way. Like I know this is web requests, and so I know how to look into the data and see that this was actually my ring jetty handler
Exactly.
and how it saw the URI and the method. And then I
Exactly.
also know like that this is a SQL call, and so I'm gonna like pull that out as a special thing.
Exactly.
And wow. Okay.
Yeah.
That's really
And
cool.
yeah, and it has been done for many other things. We're not going to go deep into this, but for example, I have been trying it for.
In that one, just so I understand again,
Yeah,
back to that
sure.
web one. Are you, was it like, oh, the namespaces like NextJDBC or something are the ones that represent the database, and the ones like, I don't know, the ones that have ringing are the HTTP
Yeah.
ones? Yeah, okay.
So yeah, this can happen because when we bring the web plugin, it's going to automatically bring, because plugins can bring instrumentation, it's going to instrument the internals. That plugin is going to instrument the internals of HTTP kit server or ring jetty, depending on what you're using. And also NextJDBC resolves it. So when we are walking over the timeline, if we know that, for example, I think it's execute all, like this is the point where JDBC next execute the sequels, for example. Okay, so we can just, if we identify that call to execute all, we grab this expression and we already have the query for example. If that makes sense. This is because we are recording not only our web application, but also Ring and yeah. So, but with that, the thing is, like, all this stuff, it's not like a general stuff, because if you're working with Clojure, like web a compiler, doesn't matter. I mean, you don't need this kind of stuff. But I find that the plugin system can be useful if in your company, in your subdomain, you know that this function calls represent transactions being made or whatever, then you can extract them from a recording by running tests and then extract it from the recording and drawing graphs and whatever you like pretty transaction looking. I have done that with also like with many other things, but also with corrasing. For example, if you have been looking at the I have a quick example here. The Corrasing Flow library, the new library that you represent graphs and processes. The only thing I'm going to show you here is that if I record here and I start a flow and I resume the flow and then put some things into channels for making the machinery do something, okay? Now I have the recordings of like my Corrasing flow system. Then I can have a plugin that says, okay, extract from flow 0 the flow shape, okay? And we can, like, I don't know, make it a little bit nicer. Whatever. And then extract the messages. Fine for messages from the same flow, because I've recorded on the same flow, and it's going to say, okay, 58 messages found. And then you can not only see the structure, but say, okay, I can double click this and I can see all these messages that went through that channel, this channel.
No way.
And if I'm interested in this channel, I can go to that particular point in time where the message is about to be in process. So that's another example of creating something for a particular domain, which is, these corrasing functions are going to be called for putting something into channels and for all different kind of things. And you can extract it and graph it and then share it. So people using Corrasing Flow can also use
that plugin, yeah.
Yeah. And here you can also like explore the messages, see in what thread it message ran. But yeah, so there's another thing I'm interested in share, because I haven't shared almost in any other, just published this plugin that I'm pretty excited about.
Okay, maybe the last thing, because we're over time.
But because there are many more things, but this is like the last thing, which is about storing those recordings and sharing them. Okay, so we can currently serialize and store recordings. And for example, let me get rid of every flow. Now we are not going to use any application. This is called the flow book. And you can like, this is basically, you record a lot of things, a lot of flows, all the interesting things, and then you save them on a file next to a flow book, which is basically like a notebook, but with points to different points in time. What this allows us is to, for example, I can load the flow book for a web application at the to-do web application, okay? And I recorded some things here already, okay? And yeah, we can, now this is coming from the disk. We can see the everything, use the stepper. We can still go and see the request that happened on flow 0, on flow 1, or whatever. You can still use the plugin, but you can also come here and open the flow book related to this, which allows which I think it's interesting to make like onboarding systems and tutorials and things for people. Like you can say, okay, loading the homepage is composed of handling the request, and now you can get into see and look around how it's handling the request work. And retrieving all to-do items from the DB. Okay, here's how we retrieve to-do items from the DB. and stuff like this, which allows us to create like much richer documentation that documents execution and makes like teaching and onboarding. And this is just like an HTML file that can point to different flow threads and ID and indexes. There's no magic
amazing. That's amazing.
to it.
Yeah.
You can write them on your. Writing this is just writing on the to-dos web app. It's just writing HTML in your editor. You can even like modify it here. I don't know, and save it and then like reload it. And I mean, it's easy to work with it. And what you use is like a special function here on Anchors, on whatever JavaScript, go to location, and you give it like a flow, thread, and index. And that's it for the people that want to develop these things. And yeah, I think that's also another, yeah. And another thing that I'm just gonna mention, but it's I have nothing for demo. It's I'm trying to implement some model context protocol to see what happens if we can give the AI make all this large language model to use the debugger for you by calling all this or looking at the recordings and ask them questions about what went there. Like if you can expose all these, and I don't know, this is like research from here now, but I'm trying to expose all the recordings to the LLMs via model context protocols, and yeah, to see what we can make from that. But yeah, that's there are, I mean, a lot of other things to show, but yeah, we don't have time.
Juan, this is amazing. I'm
Thanks.
speechless now. I need to go play with it. I actually am thinking of all sorts of ways I can use this at work and my
Sorry.
personal projects. I mean, there's just so many things where just better, doing better than print line.
Yeah.
That's really what I'm thinking of. And this is way better than print line. And the stuff you said before about how one of the problems is you have these huge nested structures and you're like trying to figure out what you've got. That's the kind of thing I'm dealing with at work all the time. And also in my personal stuff, like I'm thinking I'm just doing so many print lines just to understand what's happening in what order. And if I could just step through it and see, like that would help a lot.
I would love some feedback and there when you try to use it, and I'm always super open to like improving the experience, like trying to one thing that's hard with this project is like it's hard to see how people is using it. I don't want to implement any like telemetry or anything like that, and so yeah, all feedback is welcome. If you have like new ideas or issues you find on your just let me know.
Yeah, that's absolutely brilliant one. I mean,
Okay, thanks, Ray.
I knew it was good, but I think you've added a few things in like you say, you're building it incrementally, and some of these things are just mind blowing.
So Juan, where can people get this and learn more and get involved?
Yeah, so there is the I mean, this has there's a web page which points to a lot of features and things. There is an entire user guide that it has like every feature. Everything I tried to put here, like from the quick start into like how each of the features, like searching and loops, how you handle the loops and everything. I mean, everything is also here. And you also, if you are starting, you also have an inline tutorial here. You can have the user guide here also inside the thing.
Okay.
but you can also have a tutorial here that's going to guide you like on each step, like you can try this code, look
That's
at
amazing.
here, how it's rendered. So there's an inline tutorial there also. And
Nice.
yeah, and you can also put this all in white mode.
Uh-huh.
And, if you are, and yeah,
Awesome. Awesome. So go to the webpage. I think that's looks like a
yeah.
good place to start. Flow-storm.org,
Yeah, it's
was it?
flowstorm.org.
Cool. Um, wow, Juan,
That
thank you
is
so
gonna,
much.
hey, thank you for having me. And
Yeah,
yeah,
that's absolutely sensational one. Great explanation as well, and it's the amount of work you've put into it is absolutely clear, and looks the quality looks fantastic.
thank you.
Yeah, definitely more than I was expecting. Yeah,
Hmm.
yeah. Like one of the things that I've commented on before in the closure community is there's like a lot of great ideas, and because it's a, homo iconic language, there people are able to work with the code really easily. But then there's not like a lot of follow through where the hard work of actually making it usable and, put a good interface on top of it. Like we don't do that so much, but you've done it.
Yeah.
You
I'm trying,
And a bit, and a
and I'm
lot
happy
more.
because I think we can do much better than even than other languages.
Yeah.
I have talks with people that is in this business. I have a talk with Bill Lewis that with a meet with Bill Lewis that try to present on Google like around 2000 like some time travel debugging, and we discuss some stuff. I have talks with like the undo guys. We do these kind of things for C++ and Java, and um, and I think we are like I have seen what's there, and we are in a much better position because of like S expressions and immutability
Mm,
and interactive
mm,
programming and all this stuff. And
right.
I think we can do much better
Well, the
that
fact that
other
you don't
language.
have to recompile things, you
Yeah,
just hit record and it just works. I
yeah,
mean,
exactly.
that's amazing. And
And
that's
also,
building on the Clojure platform, right?
yeah, and so yeah.
Um, wow. Okay, so thank you so much, Juan. I'm gonna wrap it up now because we're
Right,
over an hour and a half.
right.
Um, this has been apropos. It's been great to have Juan on the show. Go check out FlowStorm, flowstorm.org. Also, please subscribe so that you can know about other shows as they come out. You can also find us on the Clojurian Slack. We post the events there before they happen so that, we catch people where they are. Anything else we need to say, Ray, before we go?
No, just thanks again to Juan. I think that's been brilliant. Thank you
Yeah,
very
thanks for
much.
watching. We got 80 views on this one.
Wow.
So
Nice.
good distribution. Cool. Thank you so much,
Okay.
everybody.
Thank you for having me. Bye.
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 Mm.
Is it still live?
I just finished it just now.